I once again welcome you all of you the lecture series of electric power quality. So now we are in fifth chapter. So distributed generation and power quality. Okay. So what is the aim of this chapter? To improve the power quality by using this some distributed generating plants. So, as an electrical engineer, we are going to see how this distributed generation plants is going to helpful for improving the power quality in the power systems. We know that there are several problems occur while installing this distributed generating plants in the distribution side. At the same time, what are the different advantages it gives to the customers and all other things we are already discussed. Now we are in the topic called operating conflicts. So whether you connected this distributed generating plants to the distributed distribution side, then what are the operating conflicts? Then in the operating time, what type of problems you may get into the systems and all other things? How this will causes to decrease the quality of the power, and at the same time, how this causes to increase the power quality and all other things we are discussing in the last four classes onwards. Now, see some different types of operating conflicts we are discussed in the last classes. So, what are those utility fault clearing requirements, reclosings, interface with relaying, voltage regulation issues, and harmonics, and islanding problems, ferro resonance, shunt capacitor interaction. We are already completed these things. Okay, whether you connect our this is the sending end side, some transformers, some bus bar, whatever it may be. This is the receiving side. We are connected this DC here, distribution side. That's why we can call it as a distributed generation. So less than 10 megawatt. If the range is 10 less than 10 megawatt, then only we can call it as a distributed generating plants. Otherwise, we may call it as some another thing. So here we are connecting this plant here. So you want to estimate this one. What are the different problems while we are facing? Whether you can get this plant in this area and all other things. Okay, thus we can consider as a operating conflict. So what are the requirements it will going to add this DC to the distribution systems, and then what are the reclosing equipments we are giving to the feeder as well as the DC to protect from the external as well as the internal faults. And what are the relaying? So how this relaying equipments we are used here. So for the feeder, we are separately maintaining the relays. At the same time, DGs also we are maintaining the type of relays. Okay, then voltage regulation issues. How this DGs will produces the voltage changes, how this disease will causes the voltage changes in especially in the load side and other things. So then what are the harmonics, different types of harmonics that is going to inject DC while operating into the systems. Then what is the islanding problem? Then what are the different types of transformer connection failure problems, nothing but resonance problems, how to get into the system. Then what is the shunt capacitor interaction with the system while the DC is already operating into the distribution side, especially in the load side. So we are already discussed these key things, and then another one of the key thing is the transformer connection. You know that this DC is connected through this feeder by using some transformer. Some transformer. So, so what is the performance of the transformer while connecting this DC to these systems? Now we are going to estimate that performance is nothing but what is the some advantages, what are the some disadvantages of this transformers. Yes, transformer is considering there are different types of connection there. There star to star connection, okay, star to delta connection, then delta to delta connection. You have different types of connections are there. Delta to delta connection, delta to star type of connection is there. Different types of connections are there. So we are considering this transformer. Now we are resuming some different types of transformer connections. So how this based on this transformer connections, how, what is the performance of this DC, then and all other things, how it will be helpful to improve the power quality in the power systems, and all other things we are going to discuss in this class. Okay, now see these different types of transformer connections and all other things. Okay, first one, see here in this case, for the transformer connection, we are yes, once again at some small picture. Yes, we are receiving in voltage. This is the point of common coupling we are going to install. Now this is the transformer. Now this is the transformer. Through this transformer, we are going to add the DC. Okay, to this transformer. So now we are assuming in this four different types of transformer connection. First one is the Y-Y connection. Grounded. Grounded means here Y, nothing but delta to, sorry, star to star connection. Y-Y connection means here star connection. We also call it as a Y connection. Grounded connection. Now, first one, this one. Then what is the second one? Delta to Y connection. Delta to the Y connection. What is the third one? Delta to delta connection, or ungrounded Y to delta connection. Delta to delta connection, or ungrounded. This is not grounded to the delta connection. So this is quite opposite. Delta to Y. This is the Y to delta. So now what is the fourth one? What is the fourth one here? Grounded. This one to the connection delta. Now these are the four different types of connections we are going to use to connect the DC to the fader. This is the fader of distribution fader. So this is the transformer connections, different types of transformer connections. Four different here we are assuming four different types of transformer connection. First one is the grounded Y to Y connection. Now see this one symbols. Then what is the second one? So delta to Y connection. See this diagram. See this short names. Then what is the third one? Delta to delta connection or ungrounded Y to the delta. So delta to delta or ungrounded. See this Y connection are nothing but the star connection are grounded to the delta. Then what is the fourth one here? Fourth one, a grounded Y delta connection. Yes, this is a grounded Y and delta connection. Delta means here, a star. I mean, this delta connection. Now see this. Okay, so these are the four combinations of transformer connection we are going to install in this area. See this area to interconnect the fader as well as the DC. Now see this these four types. What are the some advantages? What are the some disadvantages? So now other things we are discussing here. First one connection. What is the first one? As grounded Y to Y connection. What is the first connection? Grounded Y to Y connection. Just wait. Just a minute, please, all of you. Thank you. So first connection is grounded Y to Y connection. Grounded, yes. See this, grounded Y to, yes. This is a, sorry. This is a grounded connection. Grounded Y to Y connection. Now see this grounded Y to Y connections. And the word grounded means here this neutral point. This neutral point is connected to the ground. Okay, this neutral point. Now this is the connection. This neutral point is connected to the ground. That is the connection. So what is the some advantages? So this is the most common type of the connection, whether you connect it to the three-phase loads to the some transformer connections. You know that what is the meaning of this symbols? This is the primary side. Okay, you understand? This is the primary. This is the secondary. You understand? This is the primary side connection. So okay, this is the secondary side connection. This is the primary side. This is the connection. So this. So you know that one very well. So okay. Grounded Y to Y connection means primary side we are connected the Y connection and the star connection at the same time. Secondary side also we are connecting the this type of the connection. Okay. So now see this. This is the most common type of the connection while we are installing this. So here they are connecting the Y to star Y to Y connection. This is the most common type of the connection. So it is because why it is most favorable connection, most power connection, because it reduces the susceptibility to federal resonance on cable like loads and to fewer operating restrictions when being switched to the maintenance for the maintenance. Okay, this is the main advantages. This is one of the main reason for installing this type of the connection and all other things. Okay. Continue. Okay, this is a main thing. So, what are some advantages? A main as a small advantages here in this. At the same time, you have some different types of disadvantages also there for this connection. What is the advantages? There is no phase shifting of utility side voltages. This makes detection of utility fault by DC protection relays more certain. You know that. You know that whenever you are using, yeah, people are still joining. So what about what I don't know? Okay, now see this. Yes, we are discussing this point very thoroughly. Interference with the relay. You know that whenever you add a DC to this feeder, we add DC to this feeder. Yes, see this this feeder, this DC to this feeder. You know that the relaying capability. So the area which covers the relaying, so that is reduced here. So this the area is reduced. The area is reduced. Then you call the reduction in that area, reach area, the reach that you also call it as some word, you can call it as reach. Reach of the relay is reduced because of adding this relay to this one. Okay, so if there is any problem occurred in this area, this may directly impact the systems. Okay, so that's why we are separately maintain the relaying schemes for both feeder as well as the DC to protect the internal faults. That means feeder internal faults at the same time, DC internal faults at the same time, and external faults caused by the feeder. Okay, so external faults may be some short circuit faults, some other different types of faults are there to protect the system for different faults. So to reduce this, so what is the point? This one here, this makes the detection of utility fault by DC protection relays more certain. Okay, so because of using this transformer, the relays identifying capability, the protection of that DC may increases by using this one. Then what is the second one? Less concern for ferro resonance. Okay, less concern for ferro resonance. This is one of the disadvantage while you are adding this fader. You are also discuss this one. This is mainly happening in the transformer. This ferro resonance case is mainly we are talking about the transformer. So maybe by using this type of connections, it reduces the ferro resonance in transformer. Then what is the disadvantages? This is also very important case. Whether you take any of the system, it may be advantages at the same time. It may be some disadvantages also, but it has some more disadvantages also here. What is the disadvantage? It allows DC to feed all type of faults onto the relay system. Feeding means here, if there is any fault occurred in the DC, it directly feed into the feeder also. Directly feed into the feeder also. It can allow this transformer. See this transformers allow any type of the fault to the feeder that may greatly damages the another connected loads also, another connected customers and loads and all other things. It greatly damages the systems when this faults, any of the fault is directly feed into the DC. One of the main drawback of that system. Then what is the second one? So here it can also negligence, or it can also stop the zero sequence harmonics current that might be produces some certain kinds of generators. This is very important points here. So now see these connections. Why this? why this harmonics zero harmonic current may damages the systems, why this, so it may be stop the zero harmonics or zero sequence currents to the entering into the system. This may be damages the some different types of the transfer generator connections, because especially see this a generator, we are using the word generator. So whether that DC type is a generator, connected some different types of generators. A DC is a generating some generator, we are using some sequence generator. uh, See this, it will not comes under the wind. Sorry, it will not comes under the some DC, nothing but solar and all other things plant. So it will comes under the whether we are using a generator as the source to generate the power and all other things. So because of this concern, two concerns. What are the two concerns here? So it can allows the all the type of the faults to feed into the system. At the same time, zero sequence harmonic current it will allow may be difficult to parallelize some transformer, parallel some generators. Because of these reasons, zero sequence allowing capability at the same time. So all the faults feed into the system. Because of these reasons, it is very much difficulty to parallel the generators. Okay, using some this type of the transformer connection. So we may concentrate on this point here. This is the interconnection of this point. Now see this point and this point. As a DC is a synchronous mission, nothing but a synchronous generator. Okay, on that time. So because of this zero sequence and other things, it may be produces the harmonic voltages into the system. Harmonic set to the system. A third order harmonic. You know that when compared to the all other harmonics, third order harmonics will greatly damages the systems. Okay, so to reduce that one for the transformer connections, at the same time we are also take this some which two-third of the some, connections and the pitch factors and other things we are going to maintain and things. Okay, so to limit the contribution of the generator as a ground faults, because so this is the one of the favorite. At the same time, it may also causes the greatly damages to the system, especially whenever you are using the synchronous machine as a generating uh, as a generator for DZs in this case. Okay, this is not that much preferable for DC as a synchronous generator for this connection and star to star connection. So what is the second one here? A delta to the star connection. A delta to the star connection. So nothing but a primary of this is connected to the primary side is connected to the delta, secondary side is connected to the Y connections. So this is the second most type of the connection while you are interfacing this DC to the systems. There are some advantages. What is the some advantages? So see this different types of advantages. So it may be stop the ground faults. Then what is the second one? It may be preferable to stop the third order harmonics also. This is a very good point here. So it may be to provide the insulations to protect the voltage sags and all other things. So it has some disadvantages also. What are the some disadvantages? It is difficult to predict some single line to ground faults on the second side of the voltage is relaying alone. The second side means yeah, this side. So at the same time, this point here, third order harmonics and DC may causes excessive current in the secondary side and the neutral. So these are the some drawbacks while we are using this delta to Y connection in the systems. And you can see this connection diagram. So this is the delta connection. We are connecting the primary side of the feeder. This is the secondary side. We are connecting the, now see this. This is secondary side Y connection. We are connecting this DC to that system. So these are the some transformer fuses. You know that to protect the system from the some different types of the faults. So this connection, this transformer fuses we are going to use here. Here this side also we are going to use some transformer connection. So now we'll see this. In this also, in this diagram, they can DC as a some generator. DC they are using as a some generator. So now see this, to prevent the third order harmonics from the generator, which it does not prevent the flow of the DC side. So this is the delta to Y connection type of the transformer. So you can see this. This is the delta connected to the fader side. This is the star connected to the generator. It's a DC. Now see this at DC. So first place also grounded YY connection also. This also. What is the drawback of the systems? What is the main drawback? So for the synchronous missions type of the DC, it is not suitable. So that's why we are coming to the delta to Y connection. This connection also there are some problems while considering DC as a synchronous missions. Okay, what is the third category of the connection is that one, a delta to delta connection. See this delta to delta connection R uh, or R. What is second one? Ungrounded Y. So this neutral point is not grounded. Y to the delta connection. Y to the delta connection. Okay, where you can use this type of the transformers in DC, especially in DCs like micro turbines basic systems, as well as some photovoltaic with nothing but solar cell plants and fuel cell plants, that type of plants. We are going to use the transformer delta to delta transformer or ungrounded star to delta type of transformer. Okay, so what are the what are some different types of advantages while using this type of the transformer connection? You see this. So this is a more economical transformer installation for three-phase services with some single-phase load is possible. Okay, this load is isolated from ground, single line to grounded fault on the utility side. So DC would not typically feed utility side ground faults, except when resonance occurs. Now see this ungrounded interconnection can provide for inverter based systems requiring it. These are the four different types of advantages while you are using this one. Now see this while we are discussing this one. Now see this. This is the delta to delta. In this diagram, they can give in the delta to the delta connection. So here, yes, delta to delta connection. Here, this primary side. This is the primary side, and this is the secondary side. So now we are now this diagram will indicate that islanding, isolating DC with the neutral, ungrounded service transformer connection on single line to ground fault can lead to arrested to failure. So whether there is a fault in the system, you know that failure we have to maintain separate productive scheme at the same time. Transformers also nothing, sorry, for this DZs also we are going to maintain the another different types of the protective scheme to protect the transformers and all other things, to protect the feeders. So different types of protective schemes are available. So one of the protective scheme or one of the protective device they are using here, some arrestor here. So nothing but these are some different types of the circuit breakers they are using in this one. Okay, to protect the systems from the single line to ground fault. So what are the main drawback of this connection, delta to delta connection, while we are using this one? So it is very much difficulty to identify the single line to ground fault. To identify single line to ground fault, it is somewhat difficulty to that one. Okay, these connections are highly susceptible to federal resonance. This may causes to the federal resonance problems. So it is somewhat difficult to maintain this type of the transformers also. So now another important point is three-phase switchgear may require primary on that primary. So because there are several problems that can occur if any attempts to perform single phase switching. Nothing but here you know that a single line to ground fault identification is somewhat difficult. So this will increases the cost of the interconnection. Okay. So what is the fourth one? What is the another type of the connection? The last type of the connection, grounded. Now see this. This is the grounded Y connection to the delta. grounded Y connection to the delta. Now see this grounded. Now see this grounded. See this connection grounded. See this. See this grounded Y connection to the delta. This is the one another type of the transformer connection to interconnect the DC as well as the system. Now see this. Now see the different types of the transformer connections. So see this grounded. Okay. Star to delta connection acts as a ground source feeding ground faults. Now see this. Now see this diagram. So this is the delta connection. This is the grounded Y connection. At the same time, this is the delta connection. Here, see this. This is the delta connection. See this delta connection. This is the Y connection. A grounded Y connection. So this is also the delta connection. This is also the Y connection. Nothing but star connection. Now see this. Now see this. Different types of the connections. Here, see this. Okay, now we can observe this connections. A star here there is a source here vs. So why they are taking this type of diagram and all other things? Yeah, this is very commonly used for the central station generation. Nothing but substations and all other generating plants and generating stations. We are using this type of transformer connections. Some grounded way to the delta connections. Most of the cases. So whenever you are connecting this neutral to the grounded, so single line to ground faults and other things, you are going to reduces the in the systems fader as at the same time the DC. Okay, distribution fader. So what are some advantages of this method? As a utility side, faults are easily detected because the transformer itself actually participates in the ground faults. Yes, as a utility side means here this side, this secondary side. So here they are considering a multi-grounded neutral point to reduces the impact of the single line to ground faults here. You know, see here there is some fault here. See this fault. There is some fault here. Some fault here. Okay, now see the direction of the current that is transferred. Now see this grounded directly to the any of the phase to sorry faded to the or any of the kind of transformer out of the phase connection to this transformer to the grounded neutral connections. Okay, so what is one of the advantages is that it can be actually detect the some faults, some ground faults. Then what is second advantage is here? Yes, the triplet harmonics voltages produced by this generator do not cause any current to flow because it is blocked by the delta winding. Yes, this triplet harmonics. This this is the source. As generator, it is produced by the triplet harmonics because of this delta connection. Because of this delta connection, so this triplet harmonics H is the order of 3 something is so 3 into 50 and so on is it will be easily detected as well as it will be block the harmonic current to inject into the secondary side of this fader. So to protect schemes are well understood based on the many years experience about whatever the point is common. Now series there are advantages at the same time there are more disadvantages is also there while using this grounded way to the delta connections. Okay, there's so many drawbacks is there. Now see once again you observe this one. So a source side, a generator side, we are connecting delta. Remember, secondary side of this connected to the feeder point. This transformer is connected to the feeder point. At the same time, the star is connected to the again this connection. You observe this one. The star is connected to here. See this here. The star secondary side of the star is connected to the again the primary side of the another type of the star connected transformer, and then secondary is the delta. Now see this. This primary is the delta connection. A quite opposite here. Secondary is the delta connection. This is the way to easily identify the grounding faults. But there are some different type of the uh, some different problems will occur because of these connections and all other things. So this is one of the because of this connection, it can increases the fault current. At that point, so it will leads to the interruption and reduces the reliability. So at the same time, because of this increase in fault current, it may causes to tripping of the feeder breaker and the other feeders. So at the same time, the ground trip pickup levels must be increased because you know that it is very much cautious about the ground faults. This is one of the advantages. Due to the some cases, it may going to the some disadvantages. So that's why whenever you are consider the relay, it must be take some delay in that operation. Okay. Now, what is the another drawback? Important drawback here. The sags per ground fault will generally somewhat deeper. Transfer. This because the transfer makes the system appear on more solidly grounded. So, because of this transform connection, so why? Because this is easily interconnected. This is easily identify the grounding faults. So the sags for ground faults will generally somewhat deeper for these reasons. Okay. Then what is the second another type of the disadvantage? Fee saving is being attempted because why? Because a fee saving. So you know that it can increases the fault current in the system. So when the fault current is increases, what will happen here? So the protected fuse is melted. So you know that in the uh, sorry so in the relaying concept and reclosing and interfacing of the relay, you are already discussed about the this concept called fuse saving. So why fuse saving is more important, because you know that whenever you are using fuse as to protect the system, so whenever there is a current passing on that fuse, it may be melted. But fuse, you know that fuse, manually a person has come to that point and replace that fuse. It may take the more time as well as costly also. So before activating the fuse, a recloser is activating that one and clear the fault. So this is that also we are discussed earlier. So now what is another one? So because of increasing of this fault current, it may be causes to the short circuit failure when the ground fault is occurs. Okay, so there is a point. Then what is the another point? Last point is the transformer is also subject to failure thermally. You know that when the current is increases, so thermal means the heat of the transformer may increases. It may be to reduces the performance of the transformer and to whether that relays will operate and the circuit breakers will open the transformer to the main connections. These are the some different types of disadvantages while we are using this grounded way to the delta connections. Okay, so these are the some cases. Okay, so we are discussed here four different types of the connections here. What are the different types of the connections here? A grounded Y to Y connection, delta to Y connection, delta to delta, or ungrounded star to delta connection, as well as grounded here, grounded Y to the delta connections. These are the four different types of transformer connections. We are going to add this. Okay, we are going to add this DC to the feeder. Okay, so these are the different types of transformer. So, so by the next class, we may going to see the remaining the last one. That is the so next topic we are going to see the so the remaining topic in this unit is the so it's a simple topic, but it is also more important to cover this one. This is the transformer. Sorry, whenever you are adding a DC to the low voltage distribution networks, Okay, what will happen? You know that whether you connect the DC to any of the distribution test, you have to run a test, a 5% test. You can call it as a 5% test. Whether that test is successfully done, then only you can add the DC to the uh, systems. For suppose, whenever you are adding a DC to the low voltage distribution networks, what will happen? What will happen? So, what are the some advantages? Some what is the, some disadvantages? Then how this DC will act? So, will act because of this low voltage propagation and other things. We are going to discuss in the next chapter. Okay. Yes. Thank you. Thank you for joining today's class.